This is Chapter 5, Lesson 1, Lines. So I just wanted to go over talking about the three different types of lines that you'll see. You're going to see intersecting lines, so they intersect at one point. Remember, a line is straight, okay? You can see perpendicular lines. Perpendicular lines always meet at a 90-degree angle. So again, they only cross once, but they meet at what is a 90-degree angle. Okay, and we use this symbol to represent 90 degrees. You could also have parallel lines. Parallel lines are two straight lines that never touch. So they will extend forever and infinity, but they will never touch. So let's take a look at some examples. So this says classify each pair of angles in the figure as alternate interior, alternate exterior, or corresponding. Okay, so I have my diagram over here. It says 1, 2, 3, 4, 5, 6, 7, 8. So basically I have two parallel lines. So this line is parallel to this line, and then they are cut by what's called a transversal line. Okay, so the first thing that I'm looking for are alternate interior angles. Alternate interior angles, okay? So if I'm looking at this, I'm looking at which lines, which angles are interior. They're on the inside, okay? So 4 and 3, 5 and 6 are on the inside, okay? So 4 and 3, 4 and 6 would be alternate interior angles right there. Same with 3 and 6, okay? But they want us to classify angle 1 and angle 7. Okay, so angle 1 and angle 7. So angle 1 is right here, and angle 7 is right here. Okay, so looking at these two angles, I have alternate interior, alternate exterior, and corresponding. Okay, so by looking at these and looking at where they are, you can see they're on the outside, so they're exterior angles, and they're alternate from each other. They're not right across from each other. So 1 and 7 are exterior angles that lie on opposite sides of the transversal. Remember, this line is the transversal. So they are alternate exterior angles. Okay. The other ones I have are 2 and 6. So there's 2 and there's 6. Okay. 2 is on the outside, but 6 is on the inside. So they can't be alternate exterior, and they can't be alternate interior because they're not both on the inside or both on the outside. So they have to be corresponding. So 2 and 6 are in the same position on the two lines. You can see if I have two parallel lines, they're both on the top. Okay, so they're corresponding angles. Okay. Now on page 117, you have this pink foldable. So this pink foldable kind of goes over parallel, perpendicular, and intersecting lines. So parallel lines. So in here, parallel lines will, in the first blank, you're going to write never. Never intersect, and parallel lines have the same slope. Okay. So you can see 3 and then what looks like 2 L's. That's the symbol for parallel. So it denotes parallel lines and proofs, and it's read 3 is parallel to 4. So line 3 would be parallel to 4. Okay. Next one I have is perpendicular. So perpendicular lines intersect to form a blank or 90-degree angle. In that first blank, you're going to write right. Remember, a right angle is also a 90-degree angle. The slopes of perpendicular lines are opposite reciprocals. So basically, you flip the fraction and you change the sign. So 3 is perpendicular to 4. This is the symbolism we'll use. It's an upside down T. Then for neither or intersecting, if lines intersect but do not form a right angle, they are neither parallel nor perpendicular. Slopes are not equal or opposite reciprocals. Okay? All right. So we're going to talk a little bit more about lines. Okay. So if I want to find the missing angle measures, when two parallel lines are cut by a transversal, special angle relationships exist. If you know the measure of one of the angles, you can find the measures of all of the angles. Suppose you know that angle 1, the measure of angle 1 equals 50 degrees. You can use that to find the measures of angle 2, 3, and 4. Okay? So here's my example down here. Okay? So we said measure 1 is 50 degrees. Okay? We can find measure 2 is equal to 130 because this is a straight line and it's cut by a transversal. So if I add this plus this, I will get 180 degrees because 180 degrees is a straight line. Okay? So because 1 and 2 are supplementary. So they're supplementary angles. Okay, so 1 and 2, 1 is 50, 2 is 130. Measure of angle 3 is 50 because 1 and 3 are vertical angles, okay? Vertical angles are equal to each other. And then measure 4 is 130 because angle 1 and angle 4 are supplementary, but 2 and 4 are vertical angles as well, so it's 130, okay? So example number 3 says a furniture designer built the bookcase shown. Line A is parallel to line B. Okay, so we can see my example over here. Here's line A, and here's line B. So they're parallel to each other. Okay. If measure 2, so here's measure 2, is 105 degrees, find measure 6 and measure 3. Justify your answer. Okay, so let's start with 2. So we know 2 is 105. Okay. 2 and 6 are supplementary angles. That means that they have to equal 180. So, since 2 and 6 are supplementary, the sum of their measures is 180 degrees. Measure of angle 6 equals 180 minus 105, or 75. So angle 6 is 75 degrees. Okay? Since, now I can look at 6, and then I need to find 3. Okay? Since 6 and 3 are interior angles, okay, and lie on opposite sides of the transversal, they're alternate interior angles. The measure of alternate interior angles are equal. So 6 and 3 are equal to one another, which means 3 has to be 75 degrees as well. So, since 2 and 7 are alternate interior angles, and we know that alternate interior angles are equal to one another, what is the measure of angle 7? That's right, it's 105 degrees, because 2 and 7 are equal to each other since they're alternate interior angles. All right, so we're going to talk about angles formed by transversals. So in this first box over here, okay, I have 4 lines, L, M, J, and K. Okay, and a bunch of different angles, you can see. So name that transversal. So what I want to do here is I want to name the line that's the transversal for each of these pairs of angles. So let's look at the first one. It says angle 1 and angle 12. Okay, so angle 1's here and angle 12 is here. So the transversal that cuts angle 1 and angle 12 is line L. So line L. Okay. For angles 3 and 6, okay, so here's angle 3, here's angle 6. They're cut by line J. Angle 7 and angle 15 are cut by M. And then 12 and 14, there's 12, there's 14, they're line K. Okay. So, now I want to name some corresponding angles. Okay. So, corresponding angles are angles that are cut by the transversal, but they're on the same side. So, one set of corresponding angles is 1 and 9. Okay? We can see that here's my line, they're cut by L. They're on the same side, they're both on the top. So 1 and 9 are corresponding angles. Okay. 2 and 6 are corresponding angles. Okay, so here's my two lines, they're both on the top. Okay. For for M, you could use 7 and 15. Okay. We could also use 5 and 13. That could be an option. We could use 9 and 13. Ten and 14 could be one. 16 and 12 could be one. 15 and 11 could be one. 3 and 11. 2 and 10. 4 and 12. Those could all be corresponding angles, okay? So remember, corresponding angles are angles that are on the same side of two different lines. So like 1 and 9. This line goes here, this line goes here. They're on the same side. So they're both on the top of that line. 3 and 11 are the same thing. 5 and 13. 7 and 15. 8 and 16. 6 and 14. Okay, you see the pattern? So, the next thing we have is alternate interior angles. So actually, let me, one thing real fast. So corresponding angles. So I'll color in one set of corresponding angles so you can see them. Okay, so you can kind of see the relationship. Okay. So the other thing we have is alternate interior angles. So keyword is interior. Okay, remember they're alternate. So if I have two lines and they're cut by a transversal, the inside, because it's interior, so 2 and 11 could be alternate interior angles. Okay. 4 and 9 would be alternate interior angles. 6 and 15. 8 and 13 be alternate interior angles. Okay, so that's if I'm looking at just this way. But this gives you an idea. So there's 2 and 11. You can see alternate interior angles. Okay. If I'm looking at it I'm looking at this line right here. So this is my transversal. If K is my transversal line, alternate interior angles could be 13 and 12, for 12 and 13. 11 and 14, okay? If I'm looking at J as my transversal, I could use 3 and 6 or 5 and 4. That's if J is my transversal, okay? So if L is my transversal, 2 and 11 or 4 and 9 would be my alternate interior angles. If M is my transversal, 6 and 15 or 8 and 13, okay? The next one I have is alternate exterior angles. So alternate exterior. So these are on the outside. Okay, so exterior being the key word. So if L is my transversal, my opposite outside angles, so 1 and 12 and 3 and 10 would be my alternate exterior angles. So 1 and 12, 3, and angle 10. So again, you can kind of see that are alternate exterior angles, okay? If M's my transversal, it would be 5 and 16 and 14 and 7. So I'm gonna write one of those down. 16, okay? If J is my transversal, it would be 1 and 8 or 2 and 7. And if K is my transversal, it would be 9 and 16 or 10 and 15. Okay, so those are the examples for alternate exterior angles. Okay. All right. Last thing I want to talk about is consecutive interior angles. Consecutive interior angles. So I'm looking at the transversal, and they're the ones that are right next to each other on the inside. Okay, so like 3 and 5 are consecutive interior angles. 4 and 6 are consecutive interior angles. Okay, for K it would be 11 and 13 and 12 and 14. For L it would be 4 and 11, and for M it would be 6 and 13. Okay, so you can see they're consecutive interior angles. So, ran out of room over here. 3 and 5, 4 and 6, 11 and 13, 4 and 11, 6 and 13. Okay, so these are consecutive interior angles. It's like 4 and 6 consecutive interior angles. Okay. So some non-examples could be, let's see, looking at this, 4 and 13, or 11 and 6 would be non-examples. Okay. So angle 4, 13, angle 11, angle 6. 7 and 10 would be non-examples. 1 and 16 would be non-examples. Okay. 6 and 16 would be non-examples. Okay, Okay, so 1, 16, 7, 10, 6 and 16. So those would all be non-examples. Okay. There are other ones as well. All right, so here are a couple of try it problems. Go ahead. It says angle 1 is 130 degrees. Solve for the rest of the angle measurements using what you have learned. Okay, so here's all your angles. You're putting up to angle 8, which is all the angles on there. So go ahead, pause the video, try it out, and when you're done, we will go over the answers together. All right, now that you've had a chance to try out the try it problem, let's go over the answers together. So it says angle 1 is 130 degrees. So angle 1, 130 degrees. So since we know angle 1 is 130, we can easily find angle 2, angle 3, and angle 4. We know angle 4 is also 130 degrees because angle 1 and angle 4 are vertical angles. Okay? Okay. We also know that 1 and 2 are supplementary angles, which mean they add to be 180 degrees. So 180 degrees minus 130 degrees is 50 degrees. So we can figure out angle 2. Angle 2 and angle 3 are vertical angles. So angle 3 is 50 degrees. Okay. Now, we also learned a couple of things. Okay. 4 and 5 are alternate interior angles. Alternate interior angles are the same measure. So angle 4 and angle 5 have to be the same. So angle 5 is 130 degrees, which makes angle 8 130 degrees because they're vertical angles. Okay. And then 5 and 6 are supplementary. 3 and 6 are alternate interior angles, so they also have to be the same. So 6 is 50. 7 is a vertical angle with 6. It's 50 degrees too. Okay. So for my answers, angle 1 is 130. Angle 2 is 50. Angle 3 is 50. Angle 4 is 130. Angle 5 is 130. Angle 6 is 50. Angle 7 is 50. And angle 8 is 130. And that is the end of lesson 1.